Hey, what's up guys? Ricardo here, and today we have a rather short tutorial on determining when a reaction will be spontaneous from given delta H and delta S values. So this is a sort of question which comes up commonly on the Gamsat exam for any of you studying to go into medicine. And whilst it's sort of relatively simple once you understand what to do, if you're sort of a bit lost and don't know how to go about it, it can be a rather confusing question, and you'll lose relatively easy marks which you could have got otherwise. So let's just jump into it and sort of take you through how I sort of approach these problems. First of all, we'll just do a quick recap of the actual formula, which relates spontaneity, enthalpy, and entropy, and that is change in Gibbs free energy is equal to a change in enthalpy minus T times a change in entropy. Now, we know that in order for a reaction to be spontaneous, delta G needs to be negative. So if spontaneous, delta G is equal to a negative value. Now if delta G is 0, the system is in equilibrium, and if delta G is positive, it means that it requires external energy in order for the reaction to progress. Now delta H is the enthalpy, and if you've done sort of thermochemistry, you know that a positive delta H is an endothermic and a negative is an exothermic, minus T, which is the temperature in Kelvin, times delta S, which is the entropy. And if you know thermochemistry, you'll know that a positive delta S indicates increasing chaos in the products, but a negative delta S indicates sort of less entropy or less chaos and more order. Now, let's go on to these four problems here. Now, these are the four situations you could get. Now, I wouldn't recommend memorizing it because it's always better to understand things. Once you understand how to approach the problem, you won't need to memorize it because you can always just rederive the result on the spot. And so the four situations you can get with these sort of questions is you could get both a negative delta H and a negative delta S, or both positive delta H, positive delta S, or you could get one negative and one positive. And the question might commonly asked is sort of, you've given a certain delta H and a certain delta S, and then you're given the reaction will be A, always spontaneous, B, never spontaneous, C, spontaneous at high temperatures, D, spontaneous at low temperatures. So if you want to give them a shot now, go ahead. Pause the video here and give it a shot. And so if not, we're just going to dive right into it. And the first thing I'm going to do is sort of show you how I approach these problems, how I sort of lay them out. Now I can't do this in my head. I sort of really prefer having it written down. And so let's say I'm given two positive values, so positive delta H, positive delta S. What I'll do is I'll lay it out. So I want to get a negative delta G value. That'll equal a positive, I'll put that in brackets, minus some constant T times another positive. And then I go, okay, if I have a positive subtracting a positive, so that is just like a minus. So that's just like 10 take away 10 would be 0. So we see here that if I have a positive, maybe I might like to sort of write out a value. So like say 5 minus, we'll make this sort of 3, that'll equal 2. Okay, what happens if I raise the constant a little bit? And so I go 5 minus 6. Well that equals negative 1 now. So I've got a negative value. So I have to raise this constant if I want to get a negative value. And if that's the case, that means the reaction is only going to be spontaneous at high values for T. That makes sort of sense? So that is question B there. So B is spontaneous at high temperatures. Now, let's go back and do A. Probably should have done that one first, but anyway, doesn't really matter. So we've got a negative, and that is equal to a negative value, subtracting T times another negative value. Now, a negative subtract a negative is a positive. Alright, so let's just try this way of doing things again. We got negative maybe 2, subtract negative 1. So negative negative is a positive, so that'll equal negative 1. Let's see if I raise t, what happens. If I have negative 2 minus minus, let's say 4, that's going to give me 2. So it's going to become non-spontaneous when I increase t. So therefore, if we go back over here, we know that A is only going to be spontaneous at low temperatures. Low temperatures. And so we know that because when we raise the constant, we saw that the value became positive over here. So now let's do when delta H is negative and delta S is positive. So we need a negative is equal to delta H negative. Put that in brackets just to clear things up, minus T positive. Alright, so we have a negative value subtracting a positive value. Okay, let's give that a shot as an example. Let's have negative 3 subtracting 5. That's going to be negative 8. What happens if I increase t? Negative 3 minus 10 equals negative 13. How about if I decrease t? Negative 3 minus 1 equals negative 4. No matter what I do, if I subtract a positive value from a negative value, I'm always going to get a negative value. And so C here is always spontaneous. Oh, accidentally exited out. We'll just get back in. Alrighty, let's get back to D. Alright, D. So with D we have a positive delta H and a negative delta S. So let's just do this here. We want to get a negative, and we have a positive value, and we are subtracting, put that in brackets, a negative value. A positive minus a minus is a positive plus a positive, basically. And so, I mean, that should ring some alarm bells straight away, because let's say we have 3 minus minus 2, that's 3 plus 2, which equal to 5. And you sort of see that no matter what you do to t, you're always going to add a positive value to this positive value, and so you're never going to actually get a negative. So D is never spontaneous. Now, those are the sort of 4 situations you'll get. Now, there's some graphs online which you can get, and you can sort of see, like, you know, and memorize it. You can be like, okay, delta H positive, delta S negative, that's never spontaneous. But I think that's sort of a waste of your time, and unless you really work on committing it to memory, it's not going to serve you very well. I think it's far more useful to sort of figure out a strategy on how to approach these problems. Like I've alluded to one here. If it works for you, great. If it didn't, I'm sure you can figure out your own. And I sort of like working with concrete values and sort of laying it out mathematically like this. I find it easier to actually see when it's written down rather than work it out in my head. So I hope that helped, guys. If you got any ideas for future videos, let me know. If you got any queries and you got any questions you want answered, if you see any mistakes in this videos, please let me know. Or if you got any suggestions on how to make these videos more engaging for more practice problems, although on this one it wouldn't really make a difference because there's only 4 possibilities. But hey, let me know. Alright, thanks guys, and until next time, happy studying.